Assalamu alaikum. This video is about debugging, how we can do debugging in programming languages. And debugging is a process where we can uh, check the values of different variables during running the program. It is exactly same as you do in dry runs. So I will show you how to do that in this IDE. So just remember that we can use debugging in console-based applications as well, like on command line as well. But running the debugger, which is again an application just like compiler and linker. So running a debugger in command line is a little bit different, and it would be difficult. So we can attach the debugger and we can do that, but I would not go into that. I will be doing that debugging in the IDE. So IDEs make it very easy to debug our programs, and we can check the values of variables at various stages, and I will show you how to do that. So this is a like a blank program right now. So if I declare a variable int a, and initially I do not assign it any value, and then I write, for example, a equals to 10, and then I say cout a and inline. So usually when you want to check what the value of A is at a particular moment of time, you actually do cout. So that's all we know about. Or you can also do it on the paper. But with debugging, you can check the value of this variable at the time when at the time when this variable is used. So for example, if I change this value to a plus equals to 20. So that means it should have, like my dry run would say that this program would, let me do the cout as well. So this would tell me that my program should declare a variable a, and it should have garbage value. So this is something that you do in the dry runs, right? So this is garbage at this time. Then before this variable declaration, this a is not available, so we cannot use it at all. Here we assign 10 to a, which means that now a has 10, and then we write a cout statement, which would mean that we will display 10. And here we are adding 20 to the current value of a, which is like 20 plus 10, that would be 30. And if I do cout here, it would show me 30. So that's something that you usually do. And if I run this program, it would be the same output, and you are good enough to you have a good enough knowledge to understand this. So 10 and 30. So this is how you do check the values of variables during the program. But the problem is that you get the value after this program is executed. So in debugging, I will start debugging now. The first thing is that debugging is a tool like compiler and linker, as I said earlier. So what you do is you have to have this program compiled first. So it is already compiled, and then I can say that I want to run a debugger. And debugger is can be seen here, like using F5 in this IDE. It could be a different shortcut in a different IDE, but if I go to execute, usually you will have these options together in the same menu, like compile and run, build and clean. So cleans all the intermediate files that are created. So debugger is this one. So if I run this F5 or debug, so what it would do, it would run the code, and if you see that this program has been executed, and we have not seen the output screen. It came up and it disappeared quickly, but that's not something that we want to do. So we want to stop this program at a particular line number. For example, if I want to stop it here, I can say okay. I just click here. This is a feature of this IDE. Maybe other IDEs also follow the same, because usually it's a kind of standard. Every IDE uses almost same kind of controls. So if I just click here, so you see it's a red line here, and you can see this a tick mark here, which means that when I run debugger now, it will stop here. The program will stop here, and then we can go step by step, one statement at a time. And this is called adding breakpoints. And these breakpoints you can also see uh, in the debug menu. I think it would be like this one, I guess, somewhere here. But it's the IDE dependent. You can just click here, or you can just right click here. If I just right click, and here I can see toggle, no, not the bookmark, toggle breakpoint F4. So we can add another breakpoint here, or we can remove it. So we can put multiple breakpoints, and I will tell you why we would require multiple breakpoints. So this program would stop here. So if I debug it again, so start debugging again, it's just running the program. So you see, it a screen has appeared. This one, this is my output screen. This is the second screen, and I have to align this screen like this so that you can see the audio, this output as well. So this would be tricky, but let me do it. Okay, so if you look at this screen, so this would be showing the output, and that's something that we want to see at the same time. So if you look at the IDE screen right now, I this program shows that I have declared this variable a. So it stopped here, and now I am on this line. This blue line would show that I am on this line right now, and I want to see what the value of a is before this is displayed. So that is something called adding watches. So we can watch a value of a variable, value of an expression, or uh, the values which we are interested in. We can write expressions which are not in the code as well. So, for example, if I add a watch, there are multiple ways that we can add watch. So you can see these controls appearing here when you run the debugger. The first one is debug, which we are already running, and add watch. If I do add watch, it will tell me, okay, what do you want to watch? And I can say A. So A is the variable that I want to check the value uh, at any point of time. So if you see A is equal to 0, so by default it doesn't have garbage value right now. This IDE has assigned value 0 to it, but you can see the value here. I can also look at the value by hovering over this variable, and this can tell me, okay, the value is of a is 10, a is 0 at this point, because this line has not been executed yet. I can go to that line, and I will tell how we do that. So this was one way of adding watch. The other way could be, so I can remove this watch as well. So I have this, I just right click on this, and I can modify that watch. I can remove watch. So I remove this watch. So you can see these all watches here. The other way could be like I just clicked it here right now. So other way could be just select this and then right click on this and then say add watch. So again, we can add watch in this way. I can add another watch. Let me do that, although it is not needed here. But if I say, okay, add watch, and what I want to watch, okay, because this is selected, it is not doing, but okay, add watch, and I say a multiplied by 10. So this is an expression that I have written, and this expression is not in the program, but still I can say okay, and then it says a multiplied by 10 would be 0 at this stage, at this point of time. So now coming to the execution of this program in debug mode, what I will do is I will go to the next line. So this is the next line, and the blue line shows that we are at this line, but this is not executed yet. So I can the easy way is to just go to next line. So you can see this F7 or next line. So if I just do next line, it will go move on to the next line, and you see this statement would have assigned 10 to a, and you can see a is equal to 10 and a multiplied by 10 is equal to 100. You can also add more interesting watches, like you can say a is less than equal uh, to, for example, 5. So this is a relational statement, and then it says false. So you can test different values when your program is running. So if I move on to the next line, you see, okay, here. Okay, the problem that I figured out is that when we do next line multiple times, it ends up in some error, and it can debugger cannot recover from that. So let me produce this error again and tell you how to fix it. So for example, so if I run this debugger again, so a is equal to 10, so we are here. So I do next line, it says 10, fine. This should display the value 10 on the output screen. So which means that if I do next line, this 10 would be displayed, right? So I do this 10, so this 10 is displayed. But then when I do next line, so then the next statement which is to be executed is end line, and the cursor will go to the next line, like here, and then it should come to this next line, but it is not doing so. So if I do next line, you see it has not done anything. Okay, next line, not done anything. So now if I keep on clicking, it is in error mode or some unknown state. So which means that I cannot move further. So how to fix it? There are multiple ways. For example, in your program, I tried that. I removed this end line statement and then it worked fine. But that is not the solution that I would recommend, because you would not like to change the program because just for the reasons because debugger is not working its functionality. So my solution would be to add another breakpoint, maybe after this statement, right? So I just do, because I want statements to run up till here, and then I can just jump to this line without stopping here. It doesn't mean that statements would be skipped, but it would not stop here. That's the point. So, for example, if I run this program again, but I have to compile it again, of course, because whenever you do any change, no, I have not done any changes. So I do not need to compile. I just added a breakpoint. If I run this debugger again and move this window here, so now I am on this line. I say next line, so which was like A. Okay, I do next line. It displays this 10, and I know this value of variable A is 10. Now I do not press next line because it would send the debugger into a unknown state, and it has some debug in its own. Um, so I would like to move to this line, then I can press continue. So continue statement would move me to the next breakpoint. So if I press continue, you see now I am on this line. That's fine. And then a plus 20, equal to 20. So you keep watching this value here. So if I say next line, so you see it has become 30. So we can watch the variable values during execution of the program. And then this cout a, so I say next line, you see it displays 30 and moves to the next line. Now it has not produced any error, or it understands, okay, I have to print A and then go to the next line. Here it had problem with this end line somehow. But now we see how we can do debugging or do dry run in the IDE. And then I can just say next line, and then we can just stop execution here. So for this, I had to create two breakpoints, right? Now I will change this program a little bit, which would be more interesting. This was straightforward program, so I would rather write a loop here and would like to see values of the variables inside the loop. So I just write, for example, a equals to 1 while a is less than equal to 10. So I say cout a Okay, I do not put 10 line now because that was creating problem. So I write this program, and you know what is the problem in this program. But let's see. Um, no, okay. If I change this, so this is the program now. I compile it and run it. I do not need to run it. Of course, it is like logical. I wanted to produce this logical error, and this is infinite loop, and you exactly know what is the reason. But let's do that, investigate that reason using debugger. Um, so I create this breakpoint in the beginning, or I can use this breakpoint anywhere. So, but usually we start from the beginning, so I put it in the beginning. The variable name is again the same, so I can continue using this watch, and I start debugger. Just make the screen smaller to see the output. So now the value of A is 0. Next line, now it has become 10. 10 is okay. Now we can also do this statement like I selected it, right click on this and say add watch. So now this is true. So we can see that in our watch window. So next line, because this is true, see out A, 10 would be displayed. We can see that here. A would be 11, A would get 11. So you see, you figure out that, okay, A now is 11. And we are in the test condition. 11 is greater than 10. Next line, true. So see out A, 11, A plus plus, that would become A is equal to 12. 12 is greater than 10, yes. And if I do this debugging, I can figure out quite soon that okay, the problem is that we are going in the wrong direction. So what we should have done is we should have done like if it was to display values from 1 to 10, then it had to be like a is less than equal to 10, and then a plus plus starting from 10, no 10, not so. Okay, let's try this one first. I stop this. I need to compile it again. um, Execute, compile is F9. Okay, now I run debugger again. So a is equal to 10. Next line. So a assigned 10. 10 is less than equal to 10, true. Okay, and then a plus plus, this you can see this output as well. A plus plus, next line. So 10 is now A is 11. You can see it here. A is 11. Next line. So you see A is 11 and 11 is not less than equal to 10. This condition is showing true because this was the wrong expression. We can modify this watch because this was for the previous one. We can say A is less than equal to 10. So this is our condition right now. So I can just delete it and add watch. A less than equal to 10. We can write any expression here. And now it says that this is false. So that's why we came out of this loop, and it ran only for once. And we wanted it to run 10 times. So the problem was that A was initialized with 10. So if I do it 10, then eventually I will have a correct version. So this was another example of program. Um, Okay, the last part of this debugging session is to debug a more interesting problem, which is, about Fibonacci series. We probably discussed that in the class as well. And that series is that we start with 1 and the next term is 1. So we have one term and the next term, and then we have 2, and then we have 2 plus 1 is 3, and then 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13. So that is the Fibonacci series. So we want to make a program to generate this Fibonacci series. So for example, how many terms, we can say like until this value reaches 20, so up to 20. So then that would be or 30. So then it would be 13 plus 8 is 21, and then that would be a bigger number. So we will not include that number. So how this series is generated? We have we have the first term. So I will make the simplest logic, and you can make it more efficient later on as well. But I just want to make this program and also show how we can do debugging and try to solve problems which we can have. So this is the first term, this is the second term, and then we get the third term. So okay, and this third term is actually addition of first term and second term. So if I declare variables like first term is first equals to 1, okay, that's what we want, and then second equals to 1, separated by comma, and then third equals to 0 for now, for example, because we will have to find the third term by adding first and second. So my program would be always to say uh, third is equal to first plus second, right? And and then once I have these values, I can display the values. So I can say cout first. Um, so because of this figure, I should avoid end line. But anyways, let's see. Um, \t, then second \t, and third, and of course again \t. I am also making logic for this program so that you can understand how we are doing. So let me make it full screen for the time being. Okay, so next step would be, so it would display 1, 1, and third was 1 plus 1, which was 2. That's fine up till here. It will give me the result, but I need to make this program more generic so that I can go to the next term. So I'm here right now. So next time this will have to be the same process. When I say same process, that means it has to be written in a loop so that this is executed repeatedly. But let me first write it without loop. So next time, if you look at this, it would be so we have this first term, second term, and third term, right? Now we want to move. Second term would the first term would become second term, and second term would become third term, and then third term would be addition of 1 and 2. So what we are doing here is the first is now second, second is now third, and third is now first plus second, right? So this should work. So basically, so if I think about the next term would be forget about how we print out. Next term would also be found. Okay, okay, just print them out. Cout. Uh, do we need to print first and second term? No, because like first and second terms are already printed. Now we have to just print the new term, so which is the third term. So this one followed by \t. So this would display if I just see this program, it would Did I write a cout statement? Yes, this one. So initially I had it here where I printed first, second, third, and then first became the second one, second became the third one, and third became the addition of first and second. And then I just printed this statement. That I need to print the third one. I do not need to print 1 and 2 because it is already printed. So I have to actually repeat this code. So because now I have one. So if I just write it here, so this would print 1, uh, then 1, first, second, and the third one 2. So that is something we wanted to print 1, 1, and 2. The next one is uh, then we say first is equal to second, so that what would first contain? So that would be seen in the debugger, second, third, and then we display the third. So we already have displayed printed 1, 1, and 2. So that would mean this will print 3. So this is my on-paper trial, right? So if I do this repeatedly, if I do this step repeatedly, so first is equal to second, that means the first right now uh, is 1, but now if I want to change it to 2, and then 2, the second would become the third, which is like 3. So this is 2 plus 3, and third would become 5. And then if I say cout third, it would display 5 next time. So if I do this code repeatedly, that will solve my problem. So I need to write a while loop here, which will repeat it again and again, while we say uh, third is less than equal to 30. So that's what that was our target, to print all numbers of Fibonacci series which are less than 30. So this will probably do the task. So I just remove this previous code. So 1, 1, 2, 3, 5, 8, 13, 11, 13, 21, and 34. Wow. So this 34 should not have been displayed. But now that makes a good reason to debug this program. So I have removed the watch points. I start debugging from here, and like the first line here, I want to add watch for this one, add watch, add watch for this one, add watch, and add watch for this one, add watch. So first, second, third, and then I don't think I need to do anything else. Okay, good. So next line. So you see, second is 1, and third is 0, and now third is 2, and that would display first, second, and third. We know that, okay, that would be displayed. We can see that. I can make it smaller. This one here. So this is being displayed at the same time. So next line. So keep watching these watch points because these are important for us. Okay. First becomes second. So second is 1, first is 1. So that would not change the values as such, but the values would be replaced. Second becomes third. So that means third is 2 right now. You can see it here. We cannot understand, or it's difficult to follow what is third, what is first, what is second when this series would start printing. But here it is easier that okay, second is third. That means I'm saying third is 2, the 2 would be assigned to second. So next line, so you see second is third. And third is addition of this into 2 plus 3, that would be calculated as third. You see third is displayed, and then we print the third one. You see this 3 is printed, and then I check third is less than equal to 30. So that is my condition. I can also add watch for this condition, which is true right now because third is 3. I can see it here. 3 is less than equal to 30, which is true. Okay, I move on. First is equal to second. So now we can see second. Here it was easy in the first two terms to figure out, okay, this was first, this was second. But now we do not know what is first, what is second, whether this is first or this is first. So it here, if you look at these watch points, that would make it much easier. So second is right now 2 and first is 1. And you can see if I just move on, so that would change the values. So now first is 2, second is 2, but now I want to change second to 3. So next line. So now second is has become 3. And third would be 3 plus 2, which would be 5. That's what I assume. And yes, it is showing 5. So when you do when you do debugging, you can think of value that you think that it should be, and then you do the next line, so that you can see that this program is working as per your thoughts or as per your logic. But if it generates something else, then that is the problem, and then you can immediately stop there and fix the problem. So here, if I go further, and then I want to see, okay, third is 5, 5 is less than 30, fine, okay, okay, and then I do not need to do it slowly again. But I keep an eye on this third because I want to see why it printed 34. So third is 13, so I just move on and just see, okay, the third is 21 now. Okay, 21 is less than 30, equal to 30, true. Next, next, next. Third, and third is 34 right now. You see, we entered the loop, which was the right reason. The third had to be 30, less than equal to 30, which was actually less than equal to 30. But now, after this statement, third is 34, and we did not want to print 34. And now I can easily figure out that, okay, this statement should not have been done after this addition. So if I move this statement one step up, I think that would solve the problem. So my because like if I do next line, so 34 would be printed, and now this condition would become false, and then we will end. But the problem was that we printed the value of third before uh, even if it was violating the this my test condition. So one way is to you have learned about the break statement, so probably you can use that as well. You can write if third is greater than 30, then break. So I can say it, if third is greater than 30, which is in this case, because this value changed after we checked the condition, then this cout would not work. This cout would be skipped because we'll get out of this statement. So I just run this program again. You see now it is showing the right output. The other way could be, for example, let me see if that works. If I do not print this third after doing this addition, if I do it before that, what will happen? Let's see. It might have some problem, but let's see. No, even then it is fine. Okay. So we don't have any problem here. That's an easy way to figure out how you can check the values and you can just make the program. Of course, there are many good ways to make this program. For example, here we probably will not start from 1 1. I can ask you to start, for example, from the first value. Start the first value from something else, and then you can take that value as the initial value. Um, this kind of watches and debugging is very useful when you are using nested loops, because then
It is quite interesting to see how variables are changing, the inner loop variable, the values of the inner